Students, there is one more function which is called as is.nan, and this function is also used for the same purpose. So basically, how we go about it, let's understand first. A logical vector is returned by this function, and that logical vector is indicating that all the nan values are present or not. So it returns again a Boolean value. If nan is present in a vector, it returns true or false. So basically here nan is present or not. That is found with the help of not is.nan function. Now let's see the example here. X equals to c brackets na, 3, 4, na, 0, slash 0, 0, slash 0. So you can see over here that here the values are different. Na, which is not available. Then we have 3, 4, not available. Then 0 divided by 0, and then 0 divided by 0. So here what we are doing, we are applying the function is.nan, and within the function we are passing our x vector. So x vector is basically a vector which is passing the values. And now let's see what is the output. So it indicates, so this function indicates that all the nan values are present. So here we can see the nan values are 0 divided by 0 and 0 divided by 0. So you can see over here the nan values are the last two values, and hence the output is all false. It is false, 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 false till na, and for 0 divided by 0 it becomes true. So basically nan function is returning a true if 0 divided by 0 is present, or we can say the undefined value is present, and in that case we get a true. Now let's talk about some properties of missing values. For testing objects that are na, use the function is.na. So if value is not available, we use the function is.na. For testing objects that are nan, we use the function is.nan. There are classes under which na comes, hence integer class has integer type na. The character class has a character type na. A nan value is counted in na, but the reverse is not valid. So basically a nan value can be counted in a not available value, but its reverse is not available. It's not valid. That an na value cannot be counted in a nan. So basically nan is a value where the number is not defined, or it is something which is undefined value, and in that case we use is nan. So that is how we try to find out the missing values. Now next step, we have to understand that how to remove na or nan values, that how we can remove these values from our code or from our data with the help of the code, and then see the result on the screen. So mainly students, there are two ways to remove the missing values. First way is where we are extracting the values except for na or n values. So if we are extracting the values except for na or n values, how we will go about it? Very simple. Let's have a closer look of this code and understand. We have created a variable x which is storing the value 1, 2, na, 3, na, 4, which is again a vector. Now we are creating a value d which is a logical vector, and it will store the is na result in terms of true and false. Now you can see over here that is.na is storing the result component, which is a list of true, true, false, true, false. So that result is stored in D. Now we are again calling the x function, the x variable along with square brackets, where we have applied a filter condition. You can see over here that I've applied a filter condition within square brackets. I have written exclamation D. This means that I'm negating D. So wherever D is having false, that value will be printed on the screen. Because if I see XD, D will print all the data where it is true. So if I say not D, which means not D means false. So all the values of the D is either a component true or false, as we have seen that D is a logical vector. So by default, it is true. If I see XD, it will print only NA, NA, NA. But I have done X, not D, which means negation of true, which is false. So I get the result 1, 2, 3, and 4. I can see the output that how quickly from the list of values where there are a lot of not available values, I have just applied a one line code, which is X exclamation D, where I have applied a filter with the help of D. In the square brackets, what I'm doing, I'm applying a filter, I'm putting a filter on my X data, and there I've just taken the false values on the screen, which are corresponding to 1, 2, 3, and 4. So that is how very easily I can remove NA from my data set. Now, let's take a case where I have to remove the NA or NaN, both the values. So you can see in this example, again, I have taken a variable X where there is a list of value 1, 2, 0/0, 3, NA, 4, 0/0. So you can see over here that 0/0 is my NaN value and NA is explicitly written over there. So now I print X first to see what is there in my variable X, and I see that in my variable X there is 1, 2, NaN, 3, NA, 4, NaN. And now how I am printing my value? I'm just using X, and within X I am writing is.nax. So is.na function is returning, if not applicable, it is returning true. So is.na true, and I'm doing the reverse of it. So is.na will return true and I'll negate it, which means my X will apply a filter on is.na, reverse of is.na, and it will return only false. So you can see over here that here directly I have applied is.na function and I have passed X as a parameter. So you can see that how nicely with the help of is.na function, I have applied that as a filter condition, and is.na is returning true for 0/0, NA, and 0/0. And when I apply a filter by negating it, I get the reverse, which is 1, 2, 3, and 4. So students, the modeling function in R language acknowledges a NA.action argument, which provides instructions to the functions regarding its response if NA comes in its way. So basically we can consider a particular data set, that there is a data set. In the data set, if any particular variables, any particular cell value becomes NA, which is not available, in that case, we can have an argument NA.action. And that argument can provide some instruction to the function that if that particular value is not there, what action do we have to perform, what we have to display on the screen, what suitable message should come on the screen, or where we have to land or where we have to branch if such situation arises in our data set. Suppose not applicable is there. So in that case, if that information is not there, then I will definitely go for NA.action argument. And hence, this way, the function calls one of the missing value filter functions. So now, this particular function will call a missing value filter function. Missing value filter functions alter the data set, and in the new data set, the value of NA has been changed. So you can say that the missing value filter functions will change the data set. It will change the data set, and the new data set, the value of NA is changed with something new. So that is one thing we have to understand, that with the help of missing value filter functions, we can change the values in the data set. Now suppose, take a situation where wherever there is not available coming in my data set, I want to replace that with 8, or I want to replace that with a number 6. So there is a need to change the original data set with a new value. So that situation also arises. So the default missing value filter function is na.omit. So this is the first default missing value filter function, which is na.omit. It omits every row containing even one NA. So basically what happens over here, that if any particular row where even a one not available is there, it is actually omitting, or it is rejecting that particular row. We can say it rejects the form. So some other missing value filter functions are also there, which will not work like this, which will have some more considerations and try to save your data. Because if one NA is there and the entire form is filled, so in that case, what we are doing? We are rejecting the data, a huge data, just because one value was not present over there. So students, missing value filter functions are of 4 types, and let's see what are these 4 functions. So the first function, as we know, is na.omit. This omits every row containing even one NA. So basically, suppose my data is such, if I'm performing a scientific research and my data is such that it is very critical and I cannot compromise with any of the missing values, because if I assume and put something else over there, it can create a chaos in my results, or it can change my results abruptly, or I cannot rely on such kind of assumed values. So in that case, what I will do? I will omit every row containing even one NA. So this is the first missing value filter function. The second missing value filter function is na.fail. Now na.fail is a missing value filter function which halts and does not proceed if NA is encountered. So basically, if I have na.fail, in that case, if there is one not available data, in that case, it will halt the code, it will halt the program, or it will stop the program, but not ignore the record, which means that I'm not ignoring the record, but I'm halting my program for some purpose. So if I want to halt my program and I want to give a message, or I want to procure the data from somewhere else, in that case, I will go for na.fail. Next, we have na.exclude. Excludes every row containing even one NA, but keeps a record of their original position. So this is a better version of na.omit, because in the na.omit, we were omitting every record containing even a single NA. But here na.exclude is actually excluding the rows from the data set, but it is keeping a record that which particular position is not having the data. So this is kind of producing a little report to be referred further, that from this data set, there are these many values not available, and at this locations, these are not available. So what we can think about it, that we can procure that data again through some other ways at that particular location. If suppose I want to have some data, and again I want to refill that data into my original file. So basically na.exclude is making two sets of data. One is the rows which are having all the values, and one is the data set where every row is having even one NA. So this is the third type of missing value filter function. And the last one is na.pass. It just ignores NA and passes throughout. This means that this last function na.pass is a function which will ignore the NA, and it will consider all the rows of a data set. So sometimes there is a situation where we can manage to ignore the not available values, and still we can process the data, because sometimes the values are not very crucial, and we can have certain assumed values through finding out the median or the mean, and we can refill that value, that assumed value, into the database. So there we can ignore NA and we can move ahead in the data set.